Good evening, everyone. Today I'm going to present a presentation on the topic N-Client Optimizer. So here we go. The contents are listed here that I will be explaining today. So coming to the introduction part, the N-Client Optimizer is a NASA-inspired optimization algorithm. It was developed by and proposed by Syed Ali Mirza in 2015. It is based on hunting behavior of ant lions, which are the insects that trap ants in sand pits. So this was the introduction part. Coming to the next slide, why need for the optimization? So why do we need optimization algorithms? So many real world problems are very complex. We know. So for example, minimizing power loss, improving battery efficiency, that's etc. are uh, very complex to solve. So, normal mathematical method may fail because problems are nonlinear. Many variables exist, and solutions may get stuck in local minima that I have written here, and need balance from between exploration also and exploitation also. So, for these problems, we use algorithms like Ant-Line Optimizer, PSO, etc. So that's all we uh, that is why optimization needed. So coming to the next slide, uh, for this algorithm has a biological inspiration, that is uh, uh, ALO copies how antlion create and hunt create sorry biological inspiration is that ALO copies how antlions hunt ants in nature. So the hunting process is that antlion digs a cone shaped pit. The pit acts like a trap. And step 2, ants move randomly. Step 3 is antlion stems and capture ants. Antlion throws sand. And step 4 is antlion catches the ant. So that's these are the steps. So coming to the next slide, the main idea of ALO is that in the algorithm, ants represent candidate solutions. Antlions represent promising solutions. Best antlion is called elite. And the goal is that the goal is that ants search randomly, endless guide them, and best solution survives. So coming to the next slide, random walk, that is ants move randomly in search spaces. So this random movement is called random walk. So it helps exploration, prevents premature convergence, and the purpose is that explore many possible solutions, avoid getting trapped, search globally. So at the beginning, a movement is large and exploration is high. Later, movement becomes smaller and exploration increases. That is the random walk. So coming to the next slide, trapping mechanism. The trapping mechanism is that antlions influence and movement, search boundaries shrink gradually, and it improves exploitation. That is the trapping mechanism. So coming to the next slide, roulette wheel selection. That is, I'm going to explain. So not all antlions are equal. So better antlions have higher probability to attract ants. This is done using the roulette wheel selection. So meaning is that stronger solution influence more ants, weak solutions influence less. So this improves optimization speed. Coming to the next slide is that adaptive boundary reduction. So when an ant falls into the pit becomes tighter. The ant moves closer to the center. So search radius decreases with iterations. Early iteration exploration and later iterations are exploitation. The result is that. Coming to the next slide, that is the elitism in ALO. The concept is that the best antlion found so far is called the elite. That is the concept, and the elite solution is always preserved. So every ant is influenced by uh, selected incline and elite incline. The advantages is that prevents losing base solution, increases accuracy, improves convergence. That's are the advantages. So coming to the next slide, the ALO algorithm steps. That is the complete working process. So the complete working process is that step one is that initialize ends and inclines, evaluate fitness, and select inclines using roulette wheel. Uh, for number third also random walk of ends, update positions and replace weaker inclines, and six repeat until the maximum iterations. That's are the ALO algorithm steps. So coming to the next slide, the advantages. The advantages of ALO is that it is a simple implementation, and it avoids local optima, code conversion speed, strong exploration is also the advantages. So many advantages are there. Uh, Works for many optimization problems. That is one advantage. Requires few control parameters. That is one advantage. So these are the advantages. Coming to the disadvantages. Next slide. Coming to the disadvantages is that random walks increase computational time. Performance may reduce for very large problems. Can become slower in high-dimensional systems, and then these are the disadvantages. So coming to the next part, the applications. The applications is that are that ALO is used in many engineering fields, such as in electrical engineering, in artificial intelligence, in mechanical engineering, in renewable energy, etc. So in electrical engineering, it is used in MPPT optimization, PID tuning, power system optimization also, and in artificial intelligence, it can be used in neural networks, structural machine learning optimization. And coming to the mechanical engineering part, it is used in structural design, gear train optimization, uh, and many other applications are there. And coming to the renewable energy part, it is used in solar optimization, wind energy systems, etc. etc. So these are the applications. So coming to the next slide, comparison with PSO. PSO is nothing but the same as ALO, an algorithm that is used to optimize. So the uh, comparison is that in ALO is random walk based, and it has better local minima avoidance. And in PSO it is velocity based and faster but may stagnate. And many other comparisons also, many other differences, such as exploration. For exploration, the ALO is strong, but PSO is moderate. For complexity, in case of complexity, the ALO is moderate, but PSO is simple compared to ALO. And ALO is inspired from incline hunting, as we know, and PSO is inspired from bird flocking. So that is the comparison between these two algorithms. Sorry. So coming to the next slide, engineering applications are there also. So the main engineering applications are cantilever beam design, gear train optimization, ship propeller optimization, three bus thrust problem, etc. etc. So results showed that it has better accuracy, faster convergence, fewer function evaluations. So that's all the engineering applications. Coming to the next slide. So we can conclude that the incline optimizer is a powerful swarm intelligence optimization technique inspired by nature. It effectively balances exploration and exploitation to find global optimum solutions. So it helps in avoiding local optima and finding accurate global solutions, etc. So Uh, it also shows strong performance in solving complex multidimensional engineering problems. So we conclude that it is considered a reliable and efficient optimization technique in modern engineering applications. So we come to know that it effectively balances exploration and exploitation to find global optimum solution, etc., etc. So now we conclude that it is a nice. It is one of the best optimizer between PS also. So we can conclude that it is a reliable and efficient optimization modern optimization technique in modern engineering applications. So that's all. Uh, Finally, thank you for listening. So these are the contents we have discussed in this slide in this presentation. So I hope you have understood what I am trying to tell. That's all. Thank you.